with the question, is Yellowstone gonna blow?
When it hits, first of all, very few people survive and everything goes to shit.
Deep in the heart of Yellowstone, a massive supervolcano with the power to destroy continents is quietly brewing. Experts have now begun to warn that this remarkable geological marvel, known for erupting every 600,000 to 800,000 years, now poses the greatest threat ever to life on our blue planet. A very large dome-shaped uplift is steadily growing, accompanied by unsettling shifts in Yellowstone Lakes water levels and a mysterious 100-foot crack tearing the Earth apart, all hinting at a potential and very deadly crisis. And with Joe Rogan's serious warnings, some very shocking realities are beginning to emerge. Is the giant awakening? And are we standing on the brink of an unimaginable geological apocalypse? Join us as we unravel how Yellowstone System Alert has just announced that the massive dome-shaped uplift is increasing in size, and how this could spell destruction for our planet as we know it. Yellowstone National Park. Nestled within the untamed expanse of the American West lies Yellowstone National Park, a breathtaking testament to nature's splendor and a geological puzzle that spans an impressive 2.2 million acres. This marvel stands atop one of the world's most captivating volcanic systems, molded by giant-sized geological forces over countless eons. Often concealed beneath the surface, the park occasionally unveils itself in awe-inspiring displays. Monitored vigilantly by the United States Geological Survey, this supervolcano possesses the potential for global catastrophe, remaining dormant for over 64,000 years. Its legacy is etched in immense calderas and resurgent domes, born from cataclysmic events that shaped the landscape. What revelations can be gleaned from Joe Rogan's unfiltered perspective about these seismic shifts? How do his insights intertwine with recent surprising geological transformations, especially in the context of a potential Yellowstone eruption? To unravel this captivating narrative, we must embark on a journey into the very heart of this mysterious Yellowstone caldera. The Yellowstone Caldera. The Yellowstone Caldera, a massive crater, took shape during the final of 3 super eruptions spanning the past 2.1 million years. These cataclysmic events not only molded the park, but also left an enduring impact on the entire region, a legacy that continues to captivate geologists and scientists today. The most recent eruption, around 631,000 years ago, spewed an astonishing 1,000 cubic kilometer of material, blanketing much of North America in ash and altering global climate patterns. But what unfolds after such a colossal eruption? Does the Earth simply move on from such a dramatic event? Not quite. In Yellowstone's case, the story persisted with the emergence of resurgent domes, a phenomenon both intriguing and significant. Following the last super eruption, the previously emptied magma chamber beneath the caldera began to refill, giving rise to a surprising geological occurrence: the formation of resurgent domes. This process led the caldera floor to swell upwards, resulting in 2 expansive dome-shaped uplifts, the Sour Creek Dome and the Mallard Lake Dome. Now, for proper understanding, let's simplify the concept of resurgent domes for a clearer understanding of this fascinating geological phenomenon. The resurgent domes. As a huge subterranean bubble swells with molten rock, similar to a balloon inflating with magma swells and extends, it exerts a tremendous force, propelling the very ground above it to rise. This process is similar to the creation of a bubble in rising bread dough, but on a grand geological scale. The landscape responds by swelling and sculpting itself into a majestic dome, giving birth to the captivating phenomenon known as a resurgent dome. These domes aren't mere gentle protrusions. They are colossal formations, each stretching over 10 kilometers in width and towering hundreds of meters above the caldera floor. Despite sharing a familial origin, The Sour Creek and Mallard Lake domes are not identical twins in either their historical narrative or structural composition. The Sour Creek Dome, a monumental mound that ascended above the adjacent caldera rim before gracefully halting its ascent. Traversing its surface reveals a mesmerizing network of faults, similar to the intricate cracks formed when the dome forcefully presses against the surrounding rock, responding dynamically to the intense warping forces. On the other hand, the Mallard Lake Dome underwent an early uplift, followed by a remarkable resurgence approximately 170,000 years ago. This resurgence left an indelible mark in the form of the Mallard Lake Rolly Flow eruption, depositing a fresh layer of rock across a substantial portion of the dome's surface, augmenting its voluminous grandeur. Significance of resurgent domes. These domes aren't merely hills, they're intricate geological marvels with a dynamic past. Beyond their imposing appearance, these resurgent domes hold vital clues about the park's geothermal activity and potential volcanic events. The uplifting and reshaping of the caldera floor, as showcased by these domes, hint at Yellowstone's volcanic system being anything but dormant. Beneath its serene surface, a restless giant stirs, altering the very ground beneath our feet. What seems like a simple revelation is just the beginning. Brace yourself for a seismic shockwave of discovery about to unfold. Joe Rogan Stark, warnings. Renowned commentator and podcast host. Joe Rogan has consistently raised alarming awareness about the Yellowstone supervolcano, shedding light on the concealed threats and the potentially catastrophic consequences of this dormant giant. Rogan's discussions transcend mere conversations. They emerge as vivid and stark warnings, revealing the raw, untamed power that lies dormant beneath one of America's most iconic landscapes. In one of his compelling episodes, Rogan unveils the disconcerting reality of the Yellowstone supervolcano, suggesting that its eruption may already be underway. The notion that such a colossal force of nature might be in motion is nothing short of terrifying, amplifying the urgency of understanding its dormant yet formidable existence. Rogan goes beyond mere exposition, taking the time to articulate the genuine peril posed by supervolcanoes, with Yellowstone at the forefront of his concerns. His approach is both straightforward and profound, unraveling the complexities of geological phenomena into insights that resonate with a sense of urgency and genuine concern. It serves as a stark reminder of the immense power beneath our feet, presenting a potential scenario that could not only reshape the regional landscape, but also have far-reaching global implications. Moreover, Rogan explicitly expresses his apprehensions, issuing a compelling warning about the imminent eruption of the Yellowstone supervolcano. His words serve as a clarion call to comprehend and respect the forces of nature, which, though often silent, possess the potential to unleash devastation on an almost unimaginable scale. This perspective brings the conversation about Yellowstone and its concealed dangers to the forefront, emphasizing the imperative for increased awareness and preparedness in the face of such a colossal natural threat. Rogan's dire warnings align strongly with recent scientific discoveries that have further unveiled the mysteries of the Yellowstone caldera, reinforcing the urgency of his concerns. The unfolding narrative underscores the need for collective understanding and proactive measures to mitigate the potential impact of this dormant giant on our world. Discovery of dome-shaped uplift. Scientists have recently uncovered a dome-shaped uplift within the Yellowstone volcano system, and this revelation is sending shockwaves through our understanding of dormant volcanoes. The discovery, brought to light through the keen observations of Dr. Robert Christensen and the University of Utah's Robert Smith, raises a myriad of questions about what lies beneath. The journey into this discovery begins with a fascinating change in water levels at Yellowstone Lake, as highlighted in the captivating Inside USGS documentary. Dr. Bob Smith, captivated by subtle yet significant transformations in the Yellowstone caldera, noticed an intriguing pattern in the water levels of different parts of Yellowstone Lake. Rather than remaining consistent, the water levels varied, indicating that the entire lake basin was tilting like a seesaw. While this might go unnoticed during a stroll by the lake, to a geologist, it's a glaring signal that the ground beneath is not as stable as it seems. This tilting was not a minor event. It was a telltale sign of a significant geological shift beneath the tranquil waters. Imagine holding a shallow pan filled with water. If you tilt it slightly, the water level changes, higher on one side and lower on the other. This precise phenomenon was occurring in Yellowstone Lake, suggesting that something profound and forceful was pushing up from below, disturbing the ground and, consequently, the water above. The disturbance unveiled itself as a dome-shaped uplift, a spectacular rise of the ground described by Dr. Christensen. This uplift could be attributed to magma, the molten rock beneath the Earth's surface, pushing its way into the crust. Alternatively, it might result from the park's hydrothermal system, a network of hot water and steam expanding and pushing the ground upward. Both scenarios point to an active and changing magmatic system below Yellowstone, not in a state of slumber, but rather stirring, reshaping the landscape in ways that can suddenly become visible. Monitoring such ground deformation at Yellowstone has evolved significantly over the years, incorporating modern techniques and advanced technology, adding a layer of sophistication to our understanding of the dynamic forces at play beneath the Earth's surface. Advanced techniques for studying this deformation. In the present day, scientists employ cutting-edge tools such as GPS and INSAR to detect even the slightest movements beneath the Earth's surface. These methods represent a significant leap from past techniques, involving the use of signals from satellites orbiting the Earth to meticulously track how the ground shifts, swells, or sinks. Contrastingly, in earlier times, geodesy, a branch of Earth science focused on understanding the Earth's shape and variations, was the primary tool for studying deformation. Geodesists in the past utilized a meticulous technique called leveling to measure vertical deformation, capturing both the rise and fall of the ground. This process involved using a surveying instrument called a level and a pair of graduated staff to carefully measure elevation differences from one benchmark to the next. By repeatedly measuring these elevations across the park, scientists could construct a detailed map illustrating how the ground moved over time. The inaugural leveling survey in Yellowstone, conducted in 1923, has left a lasting legacy, with some original benchmarks still standing today. Over 500 landmarks dot Yellowstone National Park, showcasing the park's rich scientific history. A subsequent survey prompted by the 1975 magnitude 6.1 Yellowstone Park earthquake unveiled a remarkable pattern. The heart of the caldera had surged upward by more than 28 inches since 1923, with an average rate of 1.4 centimeter per year. This substantial uplift exceeded the effects of the earthquake alone, indicating that the ground was swelling and rising at a pace faster than most plants grow. Mapping changes in the ground level at Yellowstone between 1923 and 1977, scientists made a striking discovery. The ground had risen most dramatically between two key areas: the Mallard Lake and Sour Creek resurgent domes, located near iconic landmarks like Old Faithful and Lahardy Rapids. This finding adds a layer of intrigue to the geological puzzle of Yellowstone, hinting at the dynamic forces shaping the landscape over time. To grasp this phenomenon, envision the surface of a trampoline gracefully bowing under the influence of weight. Now, picture the trampoline gradually regaining its original form as the weight is lifted. This is similar to the geological drama unfolding at Yellowstone. From 1983 onward, vigilant scientists observed the ground steadily rising, a phenomenon known as uplift. This intriguing ascent persisted until 1985, when a seismic shift occurred. In that fateful year, an earthquake swarm rattled near the northwest edge of the caldera, triggering a remarkable reversal. The once ascending ground, in a process called subsidence, started sinking back down. Investigating this perplexing dance of the Earth, scientists conjectured that accumulated fluids, such as magma, hot water, and steam, had been exerting pressure beneath the surface. As these fluids escaped, the released pressure caused the ground to sink. However, the plot thickened in 1995. The behavior of the caldera floor became even more puzzling. Some parts ascended, while others descended, creating a tapestry of complexity. A new zone of uplift emerged, defying historical records with unprecedented rise rates. Amidst this geological maelstrom, scientists discerned a disconcerting connection between the erratic ground movements and earthquake swarms. It became evident that these seismic tremors and ground shifts were not isolated incidents. They were interconnected pieces of a larger, more ominous pattern. The fluctuating surface of the caldera unveiled the invisible machinations transpiring beneath, the relentless migration of magma and the intricate dance of shifting tectonic plates. The Hidden Falls Fissure. Intriguingly, in the expansive wilderness of Yellowstone Park, a startling revelation recently came to light. On what seemed like an ordinary day near the Hidden Falls in Grand Teton National Park, guides noticed a peculiar occurrence. A colossal crack, towering about 100 feet high and stretching over 300 feet long, had seemingly materialized overnight, snaking its way through a rock wall in the Teton area. The emergence of this sudden and dramatic fissure, in a region well-traveled and closely monitored, raised perplexing questions. What could have triggered the formation of this massive crack, and what significance did its sudden appearance hold in the proximity of the Yellowstone supervolcano, now ominously dubbed the Hidden Falls Fissure? The discovery sent a shiver of apprehension through both the scientific community and the public, serving as a stark reminder of nature's capriciousness. While the Teton area isn't directly atop Yellowstone's magma chambers, it maintains a close connection to the larger Yellowstone system, accustomed to the Earth's restless movements. Though discovering such fissures can be disconcerting, it's not entirely unexpected in such a dynamic landscape. However, its closeness to the colossal Yellowstone volcano has elevated concerns to a new level. The implications of the Hidden Falls Fissure reach beyond its sudden appearance. It stands as a sinister reminder of the ongoing geological processes beneath our feet. This event underscores the dynamic nature of the Earth's crust, especially in a region as geologically active as Yellowstone, highlighting the sheer unpredictability of nature. The potential eruption of the Yellowstone supervolcano becomes a significant and terrifying concern in the face of such intense geological activity. The consequences of Yellowstone eruption. Though the supervolcano's last eruption happened roughly 630,000 years ago, the real question isn't if it will erupt again, but when. Imagine a colossal magma chamber beneath Yellowstone, a massive underground expanse filled with molten rock, showcasing the sheer power and scale of the volcanic forces in action. The potential consequences of a Yellowstone volcanic eruption are nothing short of catastrophic. While there's no need to stir up panic, understanding the seriousness of such an event is crucial. Its impact wouldn't be confined to just the nearby area, but could extend globally. Yellowstone National Park sits atop one of the world's largest and most dangerous supervolcanoes. Scientists predict that when this volcano erupts again, it will unleash a force of unparalleled magnitude, unlike anything witnessed in modern times. The eruption would hurl massive volumes of ash, sulfur dioxide, and winter into the atmosphere, creating a scenario with far-reaching consequences. It's like an explosive event waiting to unfold, and comprehending the gravity of this potential eruption is essential for everyone. Yellowstone volcanic ash. The volcanic ash resulting from an eruption isn't the soft, fluffy material you might associate with fireplace ashes. Instead, it resembles fine, abrasive sand that descends from the sky, forming a thick blanket over everything it touches. The fallout from an ashfall wouldn't just be inconvenient, it would create a logistical nightmare. Roads, railways, and airports would be forced to close, making transportation nearly impossible. People in affected areas would need to seek shelter indoors to avoid inhaling the abrasive ash, which can lead to respiratory problems and damage machinery. Yet, the consequences of an ashfall extend beyond inconvenience. Roofs could collapse under the weight of accumulated ash, disrupting power supplies and causing structural damage to buildings. Moreover, ash can contaminate water sources, rendering them unsafe to drink and intensifying hardships for affected communities. While the ash clouds might be the most visible aspect of a Yellowstone eruption, the gases released during such an event could be equally, if not more dangerous. Imagine a cascade of dangers, each more threatening than the last, emphasizing the profound impact a volcanic eruption can have on the environment and communities in its path. Volcanic gases and winter. Among the primary gases released during a volcanic eruption, sulfur dioxide takes the spotlight. When this sulfur dioxide encounters water vapor in the atmosphere, it transforms into sulfuric acid aerosols. Imagine these tiny particles falling to Earth like acid rain, bringing with them potential devastation. This acidic rainfall can wreak havoc on the environment, harming water bodies, disrupting aquatic ecosystems, and jeopardizing drinking water quality. The consequences don't stop there. Vegetation, buildings, and infrastructure can all bear the brunt, posing serious health risks to both humans and wildlife. Yet, the most immediate and alarming outcome of a Yellowstone eruption is the emergence of a volcanic winter. With copious amounts of ash and gases catapulted into the atmosphere, a dense cloud forms, capable of blocking sunlight for months, if not years. Imagine a sudden and prolonged reduction in sunlight, leading to a dramatic drop in global temperatures. The repercussions of a volcanic winter are nothing short of apocalyptic. Global temperatures would plummet, causing crop failures, food shortages, and famine. Our modern society heavily relies on agriculture and global food supply chains, which would be pushed to their limits. Human populations would confront unprecedented challenges in securing food, staying warm, and maintaining basic living conditions. The mysterious aspect of a Yellowstone eruption lies in its unpredictability. Despite being one of the world's most monitored volcanoes, signs of an impending eruption are complex and subtle, earning the nickname Yellowstone being Yellowstone from the vigilant United States Geological Survey. The geological forces at play are intricate, and the indicators of an impending eruption can be elusive, adding an element of suspense to the dynamic forces beneath Yellowstone's surface. Recent research has sparked concern by suggesting that the lead-up to a Yellowstone eruption might happen faster than we previously believed. This raises crucial questions about our ability to respond effectively in the face of such an impending catastrophe. The time available for evacuations, resource allocation, and disaster preparedness would be shorter, introducing an extra layer of intrigue and urgency to the situation. Could it be that we won't know the volcano is ready to erupt until it's too late? To comprehend the possibility and potential consequences of a supervolcanic eruption, let's delve into history. Historical lead-up to Yellowstone eruption. Numerous scientists are pondering the idea that Yellowstone might erupt soon, mainly because it's been steadily growing over time. People are getting worried about how intense the eruption could be if it does happen. The Precambrian era, spanning Earth's history from its birth 4.6 billion years ago to roughly 541 million years ago, holds tales of ancient landscapes. Picture the northern Yellowstone alongside the neighboring Teton, Beartooth, Wind River, and Grove on mountain ranges as guardians of rocks aged from this remarkable period. In the western United States, Vast terrains once danced with ocean dunes, tidal flats, and expansive plains during the Precambrian, Paleozoic, and Mesozoic eras, which lasted from 541 to 66 million years ago. As time waltzed through the epochs, the Rocky Mountains emerged through mountain-building processes towards the Mesozoic's closure and the Cenozoic's dawn. The Yellowstone region, with its grandeur, unfolded in the last 66 million years. Shaped by colossal mountain building, volcanic activity, faulting, and the sculpting touch of glaciation. Venture to the park's northern and eastern edges, and you'll meet the Absaroka Range, born around 50 million years ago from a symphony of volcanic eruptions, a testament to Earth's creative forces. Amidst these ancient narratives, the current Yellowstone volcano stands as a distinct chapter, unrelated to the volcanic episodes of yesteryears. Around 30 million years ago, the landscape underwent a transformative separation, with the West's mighty waves parting along the east-west axis. This stretching tail quickened about 17 million years ago, crafting the contemporary topography with north-south valleys and mountain ranges, a hallmark of the West, including the Yellowstone region. Around 16.5 million years ago, a volcanic ballet began near modern-day Nevada, Oregon, and Idaho, with eruptions cascading from southern Idaho to Yellowstone. The North American plate, in a mesmerizing dance, glided over a shallow magma body, leaving a 500-mile path adorned with over 100 cold errors. Shifting 2.1 million years ago, the Yellowstone region found itself closer to this subterranean cauldron, and here began the saga that still echoes today. In the broader Yellowstone expanse, magma, the molten heartbeat beneath the Earth's crust, whispers its presence near the surface. Guided by the thermal convection of the mantle, magma plumes journey upwards, melting rocks in their ascent, shaping reservoirs of both molten and solid rock, an ongoing masterpiece etched by the hand of time. Beneath the Earth's surface, there's a mesmerizing dance of heat and movement that gives rise to volcanic wonders. Imagine mantle plumes as powerful conductors, transferring heat from the depths of the Earth to the crust. As tectonic plates journey over these hotspots, they leave behind a trail of volcanic activity, a dynamic testament to the Earth's inner warmth. Now focus on the volcanic hotspot currently residing beneath the expansive Yellowstone region. This hotspot has a silent force, marking its presence through volcanic deposits across Idaho's Snake River Plain. Over the past 16.5 million years, as the North American plate ventured westward, the crust's rocks melted under the influence of the mantle plume's heat. This molten magic gave birth to two magma chambers, holding a blend of partially molten and solid rock just beneath Yellowstone's surface. As the crust responded to this heat, a section above the shallowest magma chamber expanded and rose, creating a symphony of increased earthquake activity along emerging faults. The pressure built up, reaching the magma chamber, where magma found its escape through fissures. The escaping magma not only relieved pressure, but also allowed volcanic gases to make a dramatic exit, exploding into the atmosphere in a grand volcanic eruption. The aftermath was the vast amounts of volcanic ash and gas swirling into the sky, triggering pyroclastic flows of extremely hot debris over the surrounding terrain. The land above the subsurface magma chamber sank, forming the first of Yellowstone's 3 calderas. This was no ordinary event, but one of the most colossal volcanic eruptions ever witnessed, covering an astonishing 5,790 square miles of land, reaching as far as Missouri, all unfolding for 2.1 million years. The Earth's hidden dramas are unveiled in the intricate artistry of geological history. Approximately 1.3 million years ago, the Earth experienced a volcanic spectacle of epic proportions at Yellowstone. The eruption unleashed volcanic debris at a staggering scale, estimated to be a mind-boggling 8,000 times greater than the infamous 1980 Mount St. Helens eruption, which claimed lives and scorched vast lands in Washington. This ancient eruption, a colossal display of nature's might, left an indelible mark on the landscape. Later, around 640,000 years ago, another sizable volcanic event shaped the western edge of the first caldera, contributing to the formation of the current Yellowstone caldera, a colossal expanse spanning 30 by 45 miles. Since then, Yellowstone has witnessed 80 minor eruptions, each adding a unique chapter to its geological narrative. About 174,000 years ago, one of these eruptions crafted what we now know as the west thumb of Yellowstone Lake. During and after these explosive events, the caldera floor and its surroundings were transformed by vast lava flows, both viscous rhyolitic and less substantial basaltic, with the youngest, the pitchstone rhyolite flow in the southwest, aged at 70,000 years. The impact of Yellowstone's volcanic theatrics was not confined to its immediate vicinity. As the land transformed with each eruption, the continental United States wore a cloak of volcanic ash, gas, magma, and debris. Materials from these eruptions, like adventurous storytellers, traveled as far as Louisiana, leaving traces of Yellowstone's ancient, fiery whispers across the vast expanse of the continent. Now, examining previous eruptions and the lava flows that shaped Yellowstone over millennia provides crucial insights into the powerful forces at play. This wasn't a single continuous event, but rather a sequence of explosive volcanic activities, unleashing vast volumes of molten lava across the landscape. Beneath Yellowstone lies a vast magma chamber filled with molten rock, gases, and minerals. As the pressure in this chamber increased, it sought weak points in the Earth's crust to escape, resulting in the eruptions we study today. These historical eruptions were not only significant in scale, but also in the diverse volcanic phenomena they produced. Understanding this geological history adds depth to the mystery of Yellowstone, highlighting the intricate dance of forces that shape this dynamic landscape. The expelled molten lava surged across the caldera, gradually filling it with layer upon layer of molten rock that slowly cooled and solidified. These fiery flows were often accompanied by massive ash clouds and pyroclastic materials, settling over a broad area and profoundly reshaping the region's topography. The impact of these eruptions on the once rugged terrain was monumental, smoothing it over with thick, viscous rhyolite lava, creating a more uniform and expansive surface. As time passed, erosion and other natural processes worked their magic on this new terrain, sculpting valleys, canyons, and various geological features that grace Yellowstone today. The residual heat from the cooling lava also played a pivotal role in shaping the park's extensive hydrothermal system, giving life to the geysers, hot springs, and fumaroles that make Yellowstone a geothermal wonderland. The journey of magma, the molten rock beneath the Earth's crust, is a crucial part of the intricate relationship between volcanic activity and dome uplift. Following the colossal eruption that formed the Yellowstone caldera, the vast magma chamber, once emptied, embarked on a slow and relentless process of refilling. But where does this magma originate, and how does it contribute to the creation of resurgent domes, like the recently discovered one? Magma, born in the mantle beneath the Earth's crust, emerges from areas where high temperatures and pressures melt rock. In places like Yellowstone, heat from the Earth's core, along with other geological processes, creates pockets of this molten rock, adding to the mysterious forces beneath the Earth's surface. Over time, imagine a fascinating geological dance unfolding beneath the Earth's surface. Picture a mysterious force, as ancient as time itself, stirring beneath the crust, a molten concoction known as magma. Driven by both the relentless buoyancy and incredible pressures emanating from the Earth's core, this magma embarks on a journey, seeking out secret passages through fractures and zones of weakness within the crust. Envision the Earth's surface as a simmering cauldron, with the accumulating magma beneath it acting as a force of nature, exerting an upward push on the rock overhead. Think of the ground as the lid on a pot of vigorously boiling water, where the steam, like the magma, pushes against the confines above. Now, the realm of Yellowstone is a place where this pressure doesn't erupt explosively, but rather manifests as a gradual uplifting, similar to the Earth itself taking a deep breath. Meanwhile, the stage of geological intrigue was where the Sour Creek and Mallard Lake domes made their appearance. These regions, scarred by previous volcanic activity, become the focal points for the upward force exerted by the magma. The ground swelled, responding to the invisible dance below, forming majestic domes as if sculpted by the very essence of the Earth. Why doesn't this magma, this primal force, always culminate in a volcanic eruption? The answer lies in the intricate nature of the magma itself and the characteristics of the surrounding rock. Not all magma is created equal. It comes in various compositions that significantly influence its behavior. In Yellowstone, the magma often takes on a role known as rhyolitic, characterized by slow flow and the ability to trap gases, setting the stage for potentially explosive eruptions when pressure builds up. However, the saga takes a different turn when the magma finds a subtle release valve, a way to gradually dissipate pressure. Imagine the magma gently lifting the ground above, avoiding the explosive climax of an eruption. The rock above the magma chamber also plays a vital role. It needs to be robust, yet flexible, bending without breaking, forming a dome instead of yielding to the fiery forces beneath. The relationship between volcanic activity and dome uplift unfolds as a mesmerizing fabric, intricate and multifaceted. On one hand, the uplifting domes serve as clear indicators of the magmatic activity beneath the surface, signaling the accumulation of magma and the active state of the volcanic system. This upward movement can set the stage for heightened seismic activity as the Earth's crust adjusts to the shifting pressures, reshaping the hydrothermal system and carving new pathways for water and gases to reach the surface in a dynamic, ever-evolving geological symphony. All these changes are connected, like pieces in a puzzle, forming a continuous loop where each affects the others. On the flip side, the rising domes act like a safety valve for the volcanic system. They offer a gradual release of the pressure built up by the magma, potentially averting more explosive volcanic events. This doesn't mean an eruption is off the table, but the uplift of the domes becomes a key factor in figuring out how and when it might happen. So, keeping a close eye on how quickly and how much the domes lift is vital. Do you think scientists could avert this impending Yellowstone eruption in the future? Let us know your thoughts in the comments below.